So today we're going to review slope and linear functions. Okay, so what do you remember about slope? Well, hopefully when you think of the word slope, you think rate of change. Or maybe you think that's the slant of the line. That's how much it's slanted. And when we get more detail about slope, we remember that our teachers taught us it was rise over run. And what they meant by that is it's the change in y, so our vertical movement, over the change in x, that's our horizontal movement. Now, in math, we can represent change with this symbol, that's delta. That means change. So delta y over delta x is another way of saying change in y over change in x. Now, to get real specific, that means we take our y values and find their difference, and our x values and find their difference. So that is what we consider the formula for slope. That finds the slope of a line. So let's practice it. Let's find the slope. So let's say we have 2 points, and we want to find the slope. Well, to put them in that formula, we need to kind of label them. I like to call this the first point. So x1, y1, x2, y2, and now I can use that formula. So the formula says to find the slope, I'm going to take y2 minus y1, so 4 minus a negative 1, over x2 minus x1, negative 2 minus a negative 3. Now be careful here when you're subtracting a negative. That's really plus, so 4 minus a negative 1 turns into 4 plus 1. And negative 2 minus a negative 3 would turn into negative 2 plus 3, or 1. So the slope between those 2 points is a 5. x1, y1, x2, y2. Okay, so y2 minus y1 over x2 minus x1. So I get negative 4 on top. Ooh, and a 0 on bottom. That means it's undefined. Dividing by 0 is undefined. So that reminds me that we need to talk about the different, like what happens when we have a 0 in a fraction. If we had a 0 divided by 3, if I have nothing and I got 3 friends and I divide up my nothing with my 3 friends, now everybody's got nothing. But if you think about it the other way, if I have 3 apples and I'm giving them to nobody, what happens to the apples? That's an undefined idea. You can't divide up something by nothing. Okay, now if we think about it graphically, if your line is going up, increasing, that's a positive slope. If it's going down, that's a negative slope. If it's straight across, that's a 0 slope. It's not rising or falling. But undefined would mean it is a vertical line. Now let's review writing the equation of a line. Now, when we're writing the equations of a line, there's two forms of a line that are used most often. There's slope-intercept and point-slope. You probably have used slope-intercept the most, but in upper level math, we like point-slope best. So let's talk about these two forms. Slope-intercept is y equals mx. Uh-oh, that pen is dying. Can maybe get out this last part, x plus b. Oh, I need a new marker. Okay, so mx plus b. What did the m represent? That's your slope. And the b is your y-intercept. So to use slope-intercept, you really need to know the slope and the y-intercept. Now, point-slope looks like this. Let me get a different color here. Y minus y1 equals m times x minus x1. What you need to be able to use this one is you need slope. That's still my m. And you need any point on the line. That's going to go in for x1 and y1. So the only things we fill in are the slope and x1 and y1. Unless I am given the graph or the slope and the y-intercept, this is the version I usually go for. So step 2, we're going to write the equation. Given ... So the next few problems, it's all write the equation given ... Okay. So what if I'm given slope of 3/4 and y-intercept 0, -3? Well, if I'm given the slope and the intercept, the y-intercept, I know exactly what I'm going to use. I'm going to use slope-intercept. So this is my m, and b would be -3. That's super easy. But what if we're not given the slope and the y-intercept? So example 2, I mean 3, well, this would be part B. What if I'm given the slope of 4 and not the y-intercept, but a point? Let's say -1, 3. That -1 and 3 are going to go into my equation for x1 and y1. Slope, of course, is going to be my m. Now let's look at that point slope form again. It's y minus my y1 equals m and then x minus the x value. So you just plug in what you're given. The y value is 3, so y minus the y value. Slope goes in front. X minus the x value, so x minus a -1. That's going to give me y minus 3 equals 4 times x plus 1. I am fine with you leaving it there unless it says to solve for y or to write in slope-intercept form. If it did ask us to write in slope-intercept form, well, all you have to do is distribute and then add the 3 over. It's so much faster if you're going from slope and a point. Let's try it again. But this time, I'm going to be given 2 points. So let's say I have 2 points. And I need to write the equation of the line. Well, first, whichever form I'm using, the first thing is I need the slope. Need the slope. So that's going to be y2 minus y1 over x2 minus x1. I might as well make this the first point, second point. Y2 minus y1, so 6 minus a negative 3 over negative 2 minus the 4. That's going to be, let's see, that's 9 divided by negative 6. I'm going to reduce that to negative 3/2. That means that's going to be going downhill. Now that I have the slope, step 2, write the equation in point slope. It is the easiest way to do it. And what's nice is it really doesn't matter what point I use. So let's remember what point slope looks like. It's y minus y1 equals m and then x minus x1. So y minus the y value, x minus the x value. So I could do this with the first point. Y minus the negative 3 equals slope was negative 3/2 and then x minus 4. Well, that's y plus 3 negative 3/2 x minus 4. Or I could have used the other point. Y minus the y value equals the slope and then x minus the negative 2. And you're saying, Miss Zembritsky, those aren't the same equation. Yes, they are. So let's go ahead and add in the step of what if we needed to solve for y. So let's solve for y. If I distribute on that first one, I'm going to get y plus 3 equals, when I distribute, I'm going to get negative 3/2 x. Then negative 3 times negative 4 is 12 divided by 2 would be a plus 6. Then subtract 3. See what happens if I solve for y on here. I get y minus 6 equals negative 3/2 x. Negative 3 times 2 is negative 6 divided by 2. That's a negative 3. I'm going to add the 6 over. And look, they're exactly the same. So it doesn't matter which point you use, you get the same answer. Now let's also review graphing lines. Well, might as well graph that one, huh? Y equals negative 3/2 x plus 3. Remember, this means I have a slope of negative 3/2. That's the slope. And the y-intercept is the 3. Okay, so when we graph this, 1, 2, 3, 1, 2, 3, 4. I don't know how far I want to go. So y-intercept is 3. And this means we're going to go down 3, 1, 2, 3, right 2. Down 3, 1, 2, 3, right 2. And connect the dots. And done. Now, what if I had y equals negative 4? There's no x there. What that means is I have 0 x's minus 4. That's a slope of 0. That's going to be a slope of 0. That's a horizontal line at y equals negative 4. 1, 2, 3, whoops, 4. And done. Ooh, might as well do this one too. What if it was x equals 2? Well, y equals negative 4 was a horizontal line. So this is going to be a vertical line at x equals 2. Now I want to do 2 more, and I want to talk about different methods. So these are when you have a graph that is in what we call general form. There's 2 ways to go about graphing this. The first method, method 1, is to solve for y. Get y by itself. So I would first maybe move the 12. Well, actually, I can move the 3y over. That would be fine. And then I'd have 3y. Divide by 3, and I have 4/3 x minus 4 equals y. That's method 1. And that is a fine method, except for if you end up with some ugly numbers and stuff. Sometimes it can get messy. That was up 4/3. The method 2 is to find the x-intercept and to find the y-intercept from the equation. So let's think about what would happen there. If you're finding the x-intercept, you let y equal 0. Well, if I take that equation and I got 4x minus 3, replace y with 0, minus 12 equals 0. That's going to go away. And I have 4x minus 12 equals 0. That's 4x equals 12. X equals 3. There's my x-intercept. Now to find your y-intercept, you let x equals 0. So I'm going to replace that x with a 0. And guess what happens to the term that had the x? It's gone now. And I would have negative 3y equals 12. Y equals negative 4. Y-intercept of negative 4. X-intercept of 3. Makes it really fast to graph. Either way works. I just wanted to show you both. Have a great weekend.